Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship's second integrated flight test or IFT-2. So let's dive deep into it. So IFT-2 was launched on 18 November 2023. That was local time of that launch was 7:02 a.m. in the morning. In case of India, the time was 6:30 p.m. and I did a live stream in my Hindi channel, not in this one. And this was the second ever launch of full system, meaning everything was a go. Like it's supposed to work as a completely fully built rocket. So what was their aim? Aim was launch this puppy, push through max Q, go through hot staging, boost back and come and land on Gulf of Mexico. Starship orbital speed, it should reach that point, and re-entry after one orbit. Basically a fancy ballistic trajectory. Now there was no plan or aim of recovery. Let that be very clear. They were from day one. This is not like, oh, after launch they're saying that was their plan, that they're gonna launch it and they're gonna splash down on Gulf of Mexico and the Starship will splash down in Pacific Ocean. That was the whole point from day one. They were not trying to recover it. Why they were not trying to recover it? The likelihood of successful recovery was risky, to say the least. So, and be mindful, they did the same thing with Falcon 9. It took them quite a while before they, tuned everything well enough that they're like, okay, now we can, bring it back to shore, or now we can risk the, boat to capture it. So this was the aim of IFT-2. Basically behave like a rocket, just do only one orbit, almost like a, elongated ballistic trajectory. So let's understand the booster part of it. Well, all engine worked flawlessly and the power to weight ratio was significant, meaning compared to the first one, if you watch them side by side, this puppy just flew off, and basically the takeoff was much quicker and every milestone after that was also quicker, which makes sense because Starship first try was losing engine very quickly. So they started with 3 engine loss, then it became 4 engines. There there was losing engines. This puppy had all of those engines working flawlessly throughout the launch window. So they were flying. So they only took 2 seconds. Now be mindful, this was programmed. The first try they were like waiting for 4 seconds. This was a bit too much. So this time they have narrowed it down to 2 seconds. Would they try to cut off even more out of it? I do expect it. I do expect to see 1.45 seconds in the next iteration, but let's just see. 2 seconds it took liftoff, and then by 52 seconds it already reached max Q. So this puppy was pushing it hard, and after that 2.41 second it reached the hot staging part, and it was successful. If this was a rocket that was designed as a use and throw or every other rocket, this is like shut up, take money. It was a complete success. Done. Complete success. The first stage, complete success. You do not have to worry about anything else. However, one of my viewer pointed out they were seeing black plumes, and I did not see it. So I asked around, and turns out there was a orange, darkish orange and reddish plume coming out, and due to video compression in some streams it was looking like a black smoke. Now first I thought it may be hydraulic leak or something like that, but I've been assured that hydraulic numbers in this puppy is much lower compared to the Mark 1. This has electric thrusters rather than basically electric thrust vectoring compared to the hydraulic system. So it should not have enough basically hydraulic fluid to burn to give such a absolute plume. And yes, this plume is not only visible in one spectrum, almost all of them. Once you see it, you will be like, oh, I see it in all footage. And I have linked the 360 video from SpaceX on their own YouTube channel, and you can see it. Like, okay, there is a plume. And it's like almost flowing sideways. Like if the wind is there, thrust is here, like you can see a plume here. So how the heck that happened? Well, best case, let this be very clear, this is my guess, is that it may be making too much NOx like this puppy. Basically, this is a Russian bomber and the engines were not well optimized. So it was basically creating too much of a toxic environment. So it was creating too much NOx. NOx was reacting with water and it was making nitric acid. So color profile matches. That's the only reason I'm thinking is it may be the same. Now you'll be like, where is the oxygen here? Well, atmosphere has oxygen. Where is the nitrogen there? Nitrogen is more than enough in the atmosphere. So that's there. Where do you get the water from? Well, what is the exhaust product? Exhaust product is water vapor and carbon dioxide with ludicrously high temperature, which is required to make this puppy. So there is a very good chance this rocket was making nitric acid. Now, could this be present in all other rockets? Yeah, it could be present, but question is like, this is one of the most powerful rocket, and the first time we have methane rocket working at that scale. It could be true that the same thing is happening with SLS, but because of the solid booster plume, we are not seeing it. So this is just my speculation. Let the be very clear. I do not understand chemistry well enough to absolutely say that's what exactly, but the plume was clear. And once you look for it, you're like, ah, I see it. Exact same shading would be there, bit more darker. So could it be making nitric acid? Would that be an issue? Well, absolutely. That wildlife area, yeah, that goes bye-bye. If the amount that it was making, that it was visible in all of them, yeah, that wildlife area is gonna, because this puppy is corrosive AF. Not only to wildlife around it, it will damage the structures there. Like, they will notice it. If they are launching it regularly, they will notice that, hey, our paints are not lasting, our metals are not lasting. This puppy is corrosive, like not a laughing matter, it's a serious thing. So okay, they launched it, everything worked fine. What happened after that? Well, boost back. Well, booster tried to do boost back burn, it failed, and it failed spectacularly, like you can see that. So what happened? Now, as of now, when I'm making this video, the best guess is that it tried to reignite the engine, but it was suffering through too much of propellant sloshing. While we were seeing through a telescope basically, so we may think, ah, it's just a rocket that's doing that, but you have to understand, it's a freaking building that is doing, yoga cart there. So doing that, and be mindful, this thing was from day one designed to return to pad. So the amount of propellant available is also huge. So if you are doing something like a building that is going yeet, that could cause issue. That may not have enough propellant basically settling time. And not to mention, the interior of Starship does not have enough baffles. Compared to Saturn V, it does not have enough baffles. So that is a very possible explanation where they created too much propellant sloshing, which may have led to fluid hammering. And if fluid hammering happens, yeah, bye-bye your system, bye-bye. It just goes away, like basically your pipe goes boom. And do we have any indication that happened? Yes, the first engine failed, which most people are suggesting that it may have over-revved up one of the turbo pumps. That would have went boom. That would have taken out one engine next to it, because they did try to ignite the engines. The engines were working, 3 engines were working. Then one went off, other engines that were trying to be reignited, they also went off, which again, that's what people are saying. That's what is that? A turbo pump went push. That's happening there. And after that point, once computer detected enough of the engines are gone, it turns off all the system and ignites bye-bye machine. So it goes poof now. Now, assuming that's sort of thing happened, like, of course, it would be far more complex than this. But if this general hypothesis is true, could they fix it? Well, actually, yes. It's more of a matter of tuning. They were way too aggressive with it. Let's just put it that way. They were like, yeah, they have to, basically, they have to ease off on it. It's like, hey, easy, man. They have to go with the flow, man. It's like, it's one of those things. So assuming if water hammering and fluid hammering is all of those things, they should be able to tune it out and maybe add some sloshing baffles to improve the situation. So, and I do expect them to do all of them. I do expect them to, like, there is no point in just like, what if we added baffles and tried the same thing? It's like, hey, why not try both of them at the same time? So I do expect them to sort this out. Now be mindful, even without that, it is still a successful booster that is just a super heavy booster that is use and throw like every other rocket. So the booster part is success. So let's understand the Starship part of it. Now, hot staging worked as planned? Maybe. Now, why there is a maybe here? Well, chances are there was some signs that there was liquid oxygen leak. And this was again guessed out of telemetry data that the oxygen bar was going a bit faster than it should have been, and again, which could have been caused by leak. Now, where the heck the leak came from? Well, most likely leak came from quick disconnect arm. It was damaged during launch. So if it was not retracted properly, it may have left a little bit of seal there. So during the jerk of basically hot staging, it may have opened that valve system improperly, so to say, and it would have caused continuous slow leak. Or there is a good chance that overpressure happened during staging. Now be mindful, when you are talking about this sort of staging, nobody has done this sort of thing long ago. Like, nobody had this big of an engine going YOLO in such a confined space. You can run all the simulation you want. You just do not know what kind of things will happen. So there is a good chance that while the booster was reinforced like hell, the skirt that is on the upper end was not. So when they detached, for split second it may have suffered overpressure, and that overpressure could have caused some minor damage that would have caused minor leak. Because again, if the fuel leak statement is true, it must be a slow leak, because it was not leaking like whoosh, gone. It was a very slow leak. So that does make scenario that where the stressing, or basically you have stressed the metal so much that it cracked a little bit, it holds sense. And when it could have happened, it would most likely would have happened during hot staging, if that is the scenario. Now, this puppy reached almost orbital velocity. So 150 kilometers. So yes, by all definition, this puppy actually touched space, and velocity reached 24,000 kilometer, 8,000 kilometer per hour, bit less, but almost there. Almost there. They were like almost. So what happened here? Well, things went not expected. So most likely, computers did trigger a system. Computer did trigger a system. Engines were shut off. You can see that in live stream. It was like happening, and after that, poof, happened. So yeah, even this went into a boom event. And be mindful, while though that was the stage part of it, the heat tiles started to fall off during launch, and anybody who knows space shuttle may be getting flashbacks. And for Indians, it's a very serious, because again, we lost our astronaut Kalpana Chawla. So this sort of thing literally reminded me of space shuttle, where they had a foam block falling, punching a hole into the system, which, mind you, they did detected it. So same thing was happening. This is from Everyday Astronaut. He had high speed cameras, and some was very good with tracking, and you can literally see things starting to fall off. Like I would urge you, I have linked the video down below, you can see that. And once it did higher altitude, you still saw that white plume. Now why there was white plume? Well, it's a ceramic. So the moment that ceramic peels off, it was going at like supersonic speed. It's just like yeet. So there was more than enough, and you can see that, you can literally see it like completely black, slowly, okay, white, 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 white. Now, does that guarantee this would have collapsed during re-entry? Not really. Why is that? Well, compared to space shuttle, this is much more gentle. Why? Because it's a blunt body. This is just like going wabam. It's like a giant cylinder that is going through. So shock is much further away compared to having tiny wings there. So it's compared to geometry wise, this is a bit more gentle. On top of that, space shuttle was built out of aluminum. So any failure, you are going to a much weaker material. Now here you have three things. First, you have heat shield. Then you have the thermal blanket. The white thing that you see behind it, that's the thermal blanket. So most likely it still would be a fire resistant material. Then you have stainless steel. So all these three things combined should give you perfect safety. If you have few tiles falling apart, not a lot of them, few tiles falling apart, it should act as a kind of injury rather than complete failure. Again, that's a hopeful scenario. So maybe SpaceX has a data set where they're like, yeah, our simulation suggests that it should be able to successfully land if 98% of heat tiles are intact. Of course, certain edges would be like, yeah, those edges are rough. So those edges have reinforced tiles, but other things would be like, yeah, as long as majority are there, it should be like, the blunt body effect and the shock wave being far away from it. And then the fact that we have a thermal wool, and then we have stainless steel should able to sustain. So this is one of those things that we'll only find out once we actually test it. However, if that is not true, if the fact that no, bro, this needs 100% of heat tile, yeah, this failed. This failed exponentially. Heat tiles should not coming off. Like if it was coming off during max Q, that would be a thing. It started to come off during launch. And be mindful, this time we had water deluge system. So launch was not as brutal. So this is a if part. Now some people are suggesting that where tiles are falling apart, it's welding areas. You can see almost a line started to open. Those are the welding areas. They have a different kind of clamp design. Maybe they should be able to fix it, but that part is the weak link. Other than that, almost everything else I can see like working. But heat shield, yeah, that may require a bit more effort. So what about the launch pad? Well, launch pad water deluge system worked and protected the launch pad, ground asset, and the booster. The booster was healthy because be mindful, this happened the last time we tried, and this heat-rid material went into the engine itself and boomed the engine. That created a cascade failure. So for that reason, this water deluge system actually allowed this. This happened like completely intact. It's like me good, so very good. Quick disconnect arm did suffer, like it literally is bent, and then one of the hydraulic clamps is like gone. Hydraulic piston is gone. So you can see that, like you can see in the videos where like, yeah, that quick disconnect arm for some reason suffered too much damage. So that puppy has to be rebuilt, redesigned, and reinforced. So I do expect that to take some time. Water-cooled steel shower head that they are heating water outside worked very well. That's the good part. Now, as of now, current assessment is this much love should be manageable by the structure without too much hassle. And be mindful, the concrete this time around, it's a reinforced like a nuclear bunker. This nothing will happen to that. Like even if, let's say, worst case scenario, the heat plate melts through. Let's say there is some water failure, something happens. Yeah, nothing will happen to the concrete below it. Maybe other things around it will be damaged, but the concrete below is built so well this time, so overbuilt. It's like, yeah, bro, I'm not going. Like, I'm not going anywhere. So that part should be completely intact. So IFT-3 should happen very quickly as long as they can recover the basically actual data, what happened with the craft. Of course, they have to submit a report to FAA and they can get the quick disconnect arm working properly. They should have third launch quite quickly, and I do expect them to reach orbit this time. Like third time they should reach orbit reliably, unless something else happens. They should reach orbit. At least that part should be sorted by now. Recovery, that will take time, but reaching orbit should be done, and the launchpad economics is sorted. That's like, we got this, bro, we got this. So what can we expect in the future? Well, reality is SpaceX is very close to minimum viable orbital rocket. Let that be very clear. If I showed that rocket launch to any rocket engineer, to any company dealing with rockets before SpaceX, they will like, dude, this is completely successful. Yeah, oh, it detached and then it's just like went boom. Who cares? They may think like, hey, this was a planned system. It's like, hey, we have booster falling on people complaining, so we just poofed it. It's like the fact that we were trying to recover it, that's why we are like, that should have not happened. But compared to every other heavy lift rocket like SLS, it's like, bro, perfect. Booster is already done. And the fact that injured Starship almost limped to orbit, it shows the fact that if they can fix the leaking part and some overstress issues, they should have that. So my expectation is they should have very high probability of orbit by fourth launch. By fourth launch, they may be able to just risk Mark 1 satellites. The big satellites, not the tiny ones, the big ones. Would that make economical sense? Well, here's the deal. Mark 1 satellites are already outdated. They are iterating that again and again and again. Same way like Raptor 1s are already outdated. They yeeted that. This is Raptor 2. They will yeet this because Raptor 3 has already gone through testing, and Raptor 3 would be the new iteration, more refined, more robust, and has much more oomph. So same thing, it does make sense. At that point in time, like, they're like, hey, either we're going to disassemble everything and may not be useful, or maybe just test it in orbit. Maybe we'll find more detail. So I could see that by the time fourth launch, they may try just launching the Starlink satellites, the big ones, with that. Now, booster must be reused for cost reason. Can they actually run this puppy as a use and throw? Unless Artemis mission requires way too many rockets, I do not see that happening. Can they launch it? Absolutely. Can they sustain it? Absolutely. Can they make it cheaper than SLS? Undeniably. Why? Well, they are doing it mass production way. So they know the cost. They went from here to here and they are still going there. Every iteration is making each next iteration much more effective, much more quick. So it could work, but again, Artemis is not requiring, yeah, we need super heavy launches every, other month. So I don't see that economically working out. So they must need to basically get booster recovery done. Like they have to get booster done. Second stage, that's an add-on. Booster must be recovered. Like 33 engines heating is not that comfortable. Let's just put it that way. So they need time to polish. Second stage will take much longer to polish, and Starlink is running late, so they may be more forgiving to recovery. Now their speed is good. This is the one thing that we can see. Their speed is good and their rapid iteration is working. The fact that early days they were like, oh, something happened. Okay, it took this much time to take it down. This happened, then this happened. It's like, now they are just like done, like almost like a F1 pit crew. The speed that they have showed of stacking and destacking, if you have tried this with any other rocket known to man and used by system, where you're like, okay, rocket is on the launch pad and we're gonna just open it up, you're like, dude, that will take 1 month. And again, SLS, if you have seen SLS, hydrogen leaks have caused it to be redone again and again. This probably, grid fins are not working. Let's just eat the actuators out of there. Let's just do precautionary maintenance on the launch pad. What the hell? When did that happen? When did that happen in rocket industry? Where it's like, let's do maintenance on the pad. Like people were like, oh, we have cancelled it because they removed the, hot staging ring. And they're like, no, bro. And the fact how quickly they are going from taking the rocket out and taking it back up, damn, that's fast. That's freakishly fast. All those things may not sound amazing, but here's the deal. That's the most amazing part to everybody else, because even if, let's say, it takes 10 iteration to reach a completely successful system, they would reach that 10 iteration much faster than any other competitor as of now, be it national or be it private and be it worldwide. So flat out, that speed is showing here. So fastest stacking and the production mindset, the fact that they are not thinking one rocket, they are thinking this is an ecosystem. Yeet rockets, we gonna make, like, this is yesterday. This is after. Let that be clear. This is after the launch, and they have like, yeah, we have a rocket, we're ready. Basically, if they had 2 or 3 launch pad, they will be literally testing like this. Yeet. Okay, when is the next window of opportunity where, you know, the airspace is clear and water is clear? Okay, launch it then. They could do it that fast. And that is showing that's why they are not worried about, oh, it did not work. It's like, hey, did the booster work? Yes. Did the launch pad survive? Is it better than the first launch? Absolutely. So they're going. Basically, their system is paying off in spades. Assuming they do not run out of money, they also have the luxury of having a customer. Who is the customer? Starlink. Starlink is the customer. So the customer side is also sorted. So they're in a very good, healthy scenario, and their speed is good. So we are expecting some big things with Raptor 3. So this was my presentation on basically Starship's second testing. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.